All right. Well, good to see you folks. We are officially starting. This is Data Lineage in the era of AI. I'll quickly introduce myself. My name is Chad Sanderson. I am the CEO and co-founder of a company called Gable AI. I've been in data a long time. You may have seen me on LinkedIn or somewhere else. I got a book coming out in a couple months called Data Contracts, so look out for that one.
And hi, I'm Adam Sroka, a London local. I am the CEO of a company called Hypercube. We are a data and AI services company that focus predominantly on the energy sector. I've been a data scientist, a machine learning engineer, now mostly do Teams calls and PowerPoints. And we did some really interesting work alongside the incredible team at Gable that we want to talk to you about today. And some of the stuff that you can do now that like a year ago just wasn't possible with Data Lineage.
Awesome. Okay. I think everyone here has a pretty decent understanding of what data lineage is, so I'm not going to explain it except by maybe at a very, very high level, which is understanding the way that data moves across your organization. This is a really, really important thing. It's important to data analysts, to data scientists, to anyone who uses data, because data is fundamentally information. And if you don't understand where that information came from, it has no utility. So data scientists and analysts end up spending a tremendous amount of time attempting to understand what data is, where it means, and where it came from. And unfortunately, your modern enterprise really, really struggles with answering this problem. And one of the main reasons that they struggle with answering the lineage problem is that lineage is not confined to data. So when I say data, what I'm talking about is materialized objects. So this could be a table, it could be an Excel spreadsheet, it could be a Parquet file, but there's like somewhere that rows of data are being produced and it represents interactions from your customers or something else from your website. But this is actually not the origin of data. There's another half of this problem, which is the code. So all data is either produced, transformed, manipulated, or moved around by code. You usually have some engineer, or it could be a third-party system that's written an application or an API, or they're generating events, or whatever it is, but they're producing some data from somewhere, and then they're moving that data all around their data ecosystem. So it flows in through different services, it throws out of a service, into a database, out of a database, and so on and so forth. And so if you don't understand what your engineering organization is doing to code, the code they're writing to move data, the only lineage you have access to is the data that has already been produced. And unfortunately, data that has already been produced has no context, right? So records in a database don't tell you where they came from or what they mean. All right, so let's talk a little bit about invisible dependencies. So I think that one of the biggest data quality and data management problems is the fact that you have so many producers and consumers in a data ecosystem that don't know each other exist, right? You've got a software engineer, they've written an API, that API is getting consumed by a downstream system, which writes a file to Parquet, which gets loaded into a data lake, which then gets pushed into a data warehouse, and so on and so forth. And no one really understands that chain of dependencies. And when you don't understand that information, it means you don't know the lineage, and it also means you don't have a good change management ecosystem in place. Someone on the upstream can make a change to their code, which then causes a cascading effect all the way to the downstream. This is the core, I have found, of about 75 to 80% of data quality issues, whether we're talking about internal to a company or external vendors who are changing things. This is the source. A quote that I say all the time is, if nothing ever changes, then nothing ever breaks. So there's got to be a change somewhere. Okay, so here's kind of the high level of what is actually happening at these companies. So the first big problem is you've got data that's flowing across this code-based ecosystem to the downstream organizations. So you're going not just across technical boundaries, but also across organizational boundaries. Oftentimes, the people that are producing the data sit in a completely different part of the company than the people who are consuming it, and they don't talk to each other, right? You also have this hidden data coupling. So people are taking dependencies, and really they've been taking dependencies over years, sometimes decades. No one really actually understands the complex web of how data is connected across their code base and their data infrastructure. It's completely invisible. And then you have all these legacy systems. So this whole problem has existed for a very, very long time, right? Especially in the enterprise. It's not just 6 months or a year or whatever. Oftentimes it's 10, 15, 20, 30 years that this problem has been manifesting, and that's what we call tech debt in a lot of ways. And then finally there, yes, you have AI agents, and AI agents are awesome. We love AI. It's the coolest thing ever. But imagine how much this problem gets compounded if you have an agent that doesn't understand the full chain of dependencies in a data ecosystem now starting to modify code. That's a really scary thing to me, right? Some rogue system making changes to things that's not a person and can't reach out to another human being to say, hey, what are you doing with my API, right? An agent doesn't do that. All right, so what is my thesis? My thesis is that all of this data management, data lineage, it needs to shift to the left. What is shift left? Well, shift left is an engineering sort of principle or thesis. It's been around for a pretty long time. I would say DevOps kind of started it, but it's moved into security, it's moved into compliance, it's moved into a lot of other fields. And what that basically said is, if you're a downstream team and you're thinking about quality or governance or something else, you are usually reactive and after the fact, right? All you can really do is say, the quality is bad. The governance is wrong. Please, people who actually make changes and are in charge of the stuff that makes our company money, can you go and change this? And you're operating from a position of extreme weakness when you do that because you have no leverage. The engineers who make all the money have all the leverage, and you have zero. And your life is very, very difficult. And this was the position that security people were in for a long time, too. They were also after the fact. They were also going to engineers and saying, hey, guys, can you make your services more secure so if we get hacked, I don't have to deal with it? And they were also operating from a position of weakness. And what Shift Left basically said is, that's probably not the right way of doing things. Actually, what we should do is every single engineer should be responsible for quality. Every engineer should be responsible for security. If you're writing code, then you also need to think about how people are going to use the output of your code. Now, it's really difficult to ask a software engineer to start doing 10 more things. Their plates are already full. So what that requires is systems, technologies, and tools to make the lift to adopt quality, compliance, stuff like that, 10 times easier, and ideally solve new problems along the way. So I think that data management has to shift left, and to do that, it has to be real time, right? An engineer cannot be waiting around for days and days and weeks to do data management properly. It has to be developer first, and it has to be AI native. All right, so what is Gable? Gable is basically that thing that I just described. The goal is to take data management, make it unbelievably simple and easy, and put it into the hands of the software developers, and solve about 10 or 20 different other problems that they have that gets them really excited about data management. So there's 4 parts to our system. I'll go through them really quickly before I hand off. So the first thing is, we use engineering technology. We don't focus on data. We don't focus on the stuff that gets materialized. We meet the developer where they are. We look at code. So we use a concept called static code analysis. We examine code. We figure out where data is coming from in a code base, where it's going to, and we build a big graph. We then create a lot of insights from this data called data contracts. And data contracts essentially tell you who is using this data in your company, and what are they using it for, and what do they need. And this is all produced automatically. We notify developers when they make changes, how that's going to impact the downstream ecosystem. And then there's a human-in-the-loop component where data teams and governance teams can say, hey guys, you're making a whole bunch of changes upstream and you're adding features that are going to affect us. Let's have a conversation about this before you do anything. So I'm going to pass off to Adam now, who's going to talk about how Gable and Hypercube partnered to deliver this really cool functionality.
Yeah, and it was a really interesting space because I've followed Chad's writing for years, really lots of respect. Some of the engineers at Gable are incredible, and we started talking about the problem, and I got it. It's for this data, where did it come from and why? And I always thought of it as well, how do you tell the AI agent that Phil in IT chose that to be in a different table back when we did the IBM Cognos migration in 1992, and that's just the way it is now, and Phil's long retired, and so on and so forth. That is missing from the current asset. And so I got it. You take data, you take code bases, and you generate all these insights. Makes sense. The problem that then got raised was, what if you don't have a step in the middle? What if there's some sort of intermediary step of code or data that's just gone missing, right? There's a table over here that generates customer data, and there's a table over here that generates revenue, and there's some sort of missing sales piece in the middle, and nothing you can do with static code analysis is going to find that for you, right? So really interesting problem, and what we wanted to do was converge on the solution in a number of different ways, because we're talking about uncertainties. So machine learning, AI-driven use cases really work. We found, though, we had a lot of success using some pretty advanced concepts in graph theory. I'm not going to profess that it was me that did the maths here. These were math super boffins that work at Gable and Hypercube that did this. But effectively, we came up with this approach where we take those graphs that Gable is producing off of the assets it can see, the data, the code bases, and then start to generate for every unique graph it can find. Because you can imagine, right, if I'm trawling all the code and all the data, I'm going to produce graphs, but multiples, because they don't all, the whole code base doesn't all link to every other function. So they're going to exist as islands, unique graphs. Then what we do is we find similarities. We do lots of different similarity cosine and the like to find between the graphs, and come up with thresholds to cluster them by, to say, okay, what subgraphs for every graph I've got, I calculate a subgraph and find which ones are the most similar. I can then use things like scanning huge libraries of these unique subgraphs to say, well, what's the edit distance from this subgraph in this island over here to that subgraph in that island over here? And if it's small enough and below a certain threshold, well, maybe there's a missing piece of data here, or there's a missing piece of code, and then we can run that analysis and go back to the people in the business and say, does this make sense? Is there a thing here that is missing? Actually, there is this missing sales data that adds up to all these numbers if it exists. Oh yeah, it does. It wasn't included in the CRM migration that we did last year. That's why it's all gone and vanished. So it was a really interesting body of work, because we were approaching it with an AI mindset at first, but just for speed and pace. When you got into doing it using graph theory and the maths of graphs, it was much, much faster, really easy to intuit and deterministic, right? So what's the point? Why do all that? Why is it useful? What I want to do is, we do a hell of a lot of work in the energy sector. And so if we just go on to the next, I'll talk about a little bit where we are seeing this actually having an enormous impact on the way the GB energy system runs, right? So for anyone that has had the joy of working with the GB energy system, it's an incredibly reliant industry on third-party data sources. If you own a wind farm or a gas power station or a big battery, you need to know what the markets are saying, what their prices are, what the auction results are going to be. That's all regulated. You need to know the weather. You need to know what your data is doing, your asset is doing. Is it too hot? Is it got enough charge? Is it going to do the right stuff? And if we just go forward, what we're finding is that becomes quite hard to manage from a data perspective. And a lot of the work we do is helping organizations bring all that together. In the public stuff, though, so NESO, National Grid, they control the markets. Everything's open auction. So you say, I'm going to produce you a megawatt tomorrow at 3, and you can have it for £50 a megawatt, a kilowatt, whatever, right? If you win the auction, you get paid. You get confirmation you're going to get paid that. Lovely. And that happens 48 times a day, every single day, every day of the year, right? That is how we do energy in the UK, or in GB. The problem with that is every 3 or 4 days, NESO like to totally change the API, like just completely ruin, all the documents out of spec. I worked for a company previously, and we found the CSV that they posted to the website for manual download was more accurate and more up to date than the API, always. So it was quicker to write a web crawler to download that and pass that into our data store. So in that environment, right, say you come along and you buy a trading team off me, you buy an energy asset, and you want to audit the trading history of that asset. Well, how do you know? Like, I've just told you that it's 3 or 4 days is a bit of exaggeration. Every 6 days, they'll change the API. How do you go back and verify what version of the code was this built on? How do I understand what produced these numbers? Because I can't marry them up. Well, now we've got this tool that allows us to take that multi-hop step from known data, known code, to link things together and bring it into a place where you can rebuild the lineage with a high degree of confidence. And this actually is something we couldn't do like last year. Like, it wasn't possible. NISO itself looks at a thing called settlement. So I say I'm going to give you a megawatt tomorrow at 3. The grid gets it. They have to check it up to 6 or 7 times over 9 months in the future to check, is that actually what happened? This is literally how settlement in the UK works. Because it's really hard. Because if I just switch if my power station blows up or switches off, well, the energy is going to come from somewhere. How do you verify where it comes from? It's a really, really hard problem to solve. It's like usually done by 1,000 accountants that work at loads of different companies. This could legitimately change the way that it's done by being able to bridge the gap and do it at scale. And it's not something that we're talking about yet. It's a really interesting space. I think like this is a tool, and you can totally see how I'm waffling about energy trading, customer data, like addresses, tariffs, all that kind of stuff that you're more familiar with. Like, you could see how this expands to every use case for a big enterprise organization with a 30-year-old database that runs the show. So what we're going to go on to next is show you, like, well, what does that look like? And you'll be pleased to see a terminal with some like text flying really quickly. But Chad will go into the UI as well.
All right. Okay, if I hit next, does this
I think
play?
this is going to run.
Oh, yeah. Okay,
there we
it's running.
go.
Is it running? Okay, cool. Yeah, so we're just going to show you how all this works. I'm a visual person, and I just like hearing things, or I like seeing things versus hearing them. So what you're seeing right now is the Gable command line. So the way this works is you point it at a code repo. You can point it at every single code repo in your company simultaneously. And what it's doing is that it's crawling every single line of code. So it's a compiler. And then on top of the compiler is a computational engine. And that engine is sort of running all this, taking in all the useful metadata that you would get from a compiler. And it's things like, you know, where does your data flow in from? So we call that an ingress point. Where does it flow out to? What is the path between an ingress point and an egress point? How is it transformed all along the way? What is the business logic that's associated with it? Really, really, really complex stuff. But as you can see, this is a huge code base. It's running very, very, very fast. I like fast things, so we build things in Rust. And yeah, so it looks like we're basically done. This is run on a code base. And what you get out the other end is something that looks like this, kind of like a traditional lineage graph, except it doesn't apply to data. It applies to your software. This is what we call an in-service lineage graph. So it's saying within a single code base, your data is brought in on these boxes to the left. Here's the places where we're using a function to bring in data from an API, and it's going out on the right. So this is looking at a very particular API we call the Zen API, and you can see how complex it gets. Right? There's a lot of data that comes in, a lot of transformations that get applied, and this is only looking, again, within a single code base. This is why Lineage, looking outside the warehouse is almost an impossible problem, because no other system can really figure this out. Okay, so that's within a code base. We kind of have the mappings. That's in service. What this is starting to show us now is what we call cross-service. So cross-service is looking at multiple code repositories and data-oriented systems. So you can see we've got the same information here for a completely different service, but we can also look at things like databases. We can look at things like files as either sources or destinations. So here's an example of a database. Here's fields that we're able to automatically extract and say, this is the stuff that is actually moving through the organization. Here are the people who are actually consuming it all the way through. Okay, so the last thing we're going to show here is, well, this is all cool, but let's say we actually want to trace some useful information. So this shows all of the fields that are essentially available for us. Here's what we can map end to end within our company. And we've basically picked one. And Adam's going to talk a little bit more about this particular field. But essentially what this is showing is the graph view. So on the right-hand side, what we have is our in-service view, what I just showed you, right? That blue box is highlighting the particular field that we're tracing. On the left-hand side, we're showing in service, where is this data coming in from? What are the fields that are flowing in? And ultimately, how does that get transformed into the final field that we care about? Now, on the left-hand side, you see two boxes. You see a box that's kind of highlighted green and another box that's highlighted kind of in blue. The box in green is our database. So this is showing us that there are fields flowing off of this database that ultimately end up in a different service and exactly what those fields are. The blue box is a totally different service altogether. It could be an API, it could be an events, it doesn't really matter. But there's some code that's been written somewhere that's producing a set of data that ends up in the actual service that we care about. Now, I know this looks simple. This looks like, okay, yeah, pretty straightforward lineage graph. But you have to understand, at enterprise-level companies, this is millions of lines of code that have been written over the course of decades, and nobody actually understands this. It's almost impossible to look through all that code and figure out exactly how data flows from one system to another. So this is kind of the magic of what we do. There's a lot more things that Gable does, but personally, I think this is going to revolutionize how we think about data lineage. There's really nobody that's thinking about lineage in this way, and it represents about 50% of the lineage problem that's currently not being told. And just to give you a quick example, of how something like this is useful. If you've got an analyst and something starts breaking and they say, hey, my data looks wrong and I don't know why, this system can take you all the way back to the actual source and say, this is the thing, the actual thing that changed that's causing the downstream problem, and it can do it instantly. So I'm going to turn it over to Adam, who's going to talk about this very specific example and why it's useful.
Yeah, and just to pick up a point Chad said, so this Zen API is a production-grade API that we wrote that it's north of 50,000 lines of code, and all it does is get all of the kind of the data from all the various markets. There are 13 markets you can trade energy in the UK. It gets data from them all, checks auction results, and submits auctions, submits bids and offers, updates them. It's quite complicated, very heavily regulated, millions of pounds on the line, like going in and out of this. Lots of teams do this manually. We're lucky here in the UK. We have a 30-minute settlement window. In Australia, it's every 5 minutes. So you couldn't do these manual submissions there. You have to, their markets are better constructed, to be fair. What this is doing, and this is interesting, so that is like real time. You saw that run. It was like 50K lines of code. There was no database involved there, but this has picked up that, oh, well, these must come from a database because I can see database queries that are generating these insights, right? What this is doing is two things. There's an API output on the far right, the egress, right? Trade instruction summary. First of all, you say, my wind farm, I'm going to give you a megawatt tomorrow at 3 p.m. for this price, right? And you win the auction, great. So this is the top one. This is our auction results service. Well done, you. You've won the auction in this time window. Great. Make sure your wind farm's on, please, right? Later on, though, well, what if, like, was it on? Who knows? So the actual balancing mechanism service is post-fact. You go back and you say, so when you generate that data, you effectively initially create the confirm during window flag as no, because the event hasn't occurred yet, so I can't confirm that that wind farm generated that energy. What you then do is in the future, you get an update from the balancing mechanism service that says, yeah, no, we've done the check, it's been 9 months, we've done the check, that wind farm was definitely on at 3 o'clock, it produced this much. You confirm that that trade happened at that time, pay them the money that we said we would give them. And if at any point they've changed this 6 or 7 times, like the way this is run, or that wind farm gets acquired in that process, there's so many avenues through which you just might miss like that data, and the world rolls on. But these organizations are held together by like massive finance teams that manually go and verify these trades, run them through Excel spreadsheets, do lots of fudging, and we now got a tool that can do multi-hop fuzzy matching to say, actually, yeah, we are nearly there, even though you've got a data quality issue. And this is one of dozens of services within this repo, and you can imagine this is just doing what did I do with the markets. You've then got to look at what did the asset do, what did the finance team do. Like across an enterprise, this swells to a really highly dimensional problem that's really hard to tackle with humans. And we're now at a point where, yeah, we can just run code analysis and get a good insight that looks simple and easy to use pretty quickly.
Yeah. I think that this is an awesome sort of real-world use case, but there's a lot more. Compliance and governance is an absolutely huge one. So we're in production with some of the biggest banks on the planet, and a lot of that is to trace sensitive customer information. So exactly how does PII enter your system? Where are all the places does it go? What are the systems that actually have access to it for real? And what are they doing with it? So not just, it ends up in system A or it ends up in system B, but what is the code doing to that data? And is that actually allowed? GDPR is another big example of it. Like, where is customer data actually going? What systems does it end up in? Is it used in marketing? Is it used in finance? Is it used to propagate some sort of automation on the application? You have to do all this stuff manually by hand if you don't have something like this. So it's really, really cool. It's something that really is not possible without artificial intelligence and machine learning and a lot of other super sophisticated technology under the hood. OK, so yeah, that's basically our time. I think the last thing I want to say, I'll have a couple words, and then I'll let Adam kind of round us out. But I personally don't think that Lineage is just a technical problem for data engineering teams. I think when you look at, like I just said a second ago, compliance and auditing and GDPR, all the use cases within energy, it is actually a massive business concern. The entire business is really thinking about this. But I think up until now, the data organizations haven't really been able to provide super satisfactory answers at the business level, right? We can kind of tell you using Lineage what's happening within our analytical database, but that's not really the thing that most people care about, right? What they care about is, if I'm producing some incredibly important data, how do I actually know where that's going and what people are doing with it? It's the end-to-end story that has the highest utility. And I think that that side of the problem is just something that, because it hasn't been possible to solve, no one's really considered all the ramifications of it until now, which is kind of cool.
Yeah, and just to pick up on that, it's like this was only possible with quite a lot of manual effort from really highly skilled technical individuals like yourselves. And in little islands, like one system or whatever, if anyone's ever seen like a SAP implementation that's been running for decades and these kinds of things like operational technology, they produce so much bloat of like logs and data. You get a system update, all that. Like you could do parts of this before in a much smaller way, but now we're in a world where you can probably run this, crawl over your entire enterprise and get a really good, more holistic view, enabling the humans in the room to think about the problem and not just be in the weeds of like copy-pasting stuff and trying to manually suss out what was going on there. I think the implications of what this can do in the future are enormous, and it was a massively exciting project to be involved with. So.
Yeah, we've been very lucky to work with Hypercube on it. I think it's an awesome partnership. Yeah, that's our time. So. Yeah, that's it, folks. Thank you, and I guess we'll be around.
Yeah.
Do we stay up or?